In this module, we're going to talk about bond duration. And bond duration is a measure of the sensitivity of bond prices to yield changes. And it's fundamentally linked to the yield to maturity as well as the structure of the payments. But the longer the payments occur in the future, the more the bond price will be sensitive to changes in yield to maturity. Here I would like you to read in the Investopedia article, pages 27 through 33. There they discuss duration, and again, duration is sensitive to how sensitive bond prices are to changes in yields. We are going to talk about two duration measures. One of those is Macaulay duration, which is the return weighted time of the bond payments, and then modified duration, which gives percent changes in the price of the bond for changes in yields. Macaulay duration is the return weighted timing of bond payments, and we'll discuss that in the next slide. Here is the definition of Macaulay duration, and I stated this in terms for a treasury note or bond, which means that I took off the subscripts for the coupon payments because they're all the same. Here you'll see that there's a numerator and a denominator. The denominator is the price of the bond itself, and let's take a closer look at the numerator. If you look at the numerator, it almost exactly equals the price of the bond. If you replace the price of the bond, it looks almost exactly the same as what's in the numerator. The only difference is there's a 1, 2, 3, all the way up to n added for each of the cash flows. And this is the timing of the cash flows. If you look at it and you think about it a little bit, what those 1, 2, 3, and n are doing is serving as a way of weighting and each cash flow. So if we and the weights are the discounted cash flow themselves. What this Macaulay duration will give you is a number, and it will be like 3.2 years. What that will mean is that the weighted average timing of payments from this bond is 3.2 years. Most of the bonds that we look at will have durations fairly close to the length of the bond, and that's because the par value, M in this case, is much larger than each one of the coupon payments. So much more of the weight is given to the final payment. Hence, most of the time the Macaulay duration is fairly close to the length of the bond. Duration is the discounted weighted average time that payments are received on the bond, and the higher the Macaulay duration, the higher the bond price's sensitivity is to yield changes. I want to give an example of a calculation of Macaulay duration. I'm going to give it for a 2-year treasury note that we've been using as an example. Coupon rate 4% with $1,000 par. Here we're going to have yield to maturities of 0.03, 0.15. So we can calculate our discount factors off of that just like we've done before. And our discounted cash flow is our discounted factor times our payments in each one of the periods. If if we add those up, we get the price of the bond. Over here in this column, I'm going to calculate the numerator of the Macaulay duration, and that's going to be the discounted cash flow times the period of the bond, 1 in this case. Copy that down. So our fourth cash flow is 4, and as you can see, it's getting pretty large there. And then what we do to calculate the Macaulay duration is sum those terms and divide by the payment. And I always keep forgetting that I had to subtract the negative. So we have the Macaulay duration stated in terms of semi-annual periods is 3.89. Divided by 2, I get 1.94, which means you could state this Macaulay duration as 1.94 years, which means that on average the payments from this bond are 1.94 years in the future. Note that that 1.94 is very close to the maturity time of the bond, 2 years, and that occurs because if you look at the payments, the last payment by far outweighs any of the other payments. So we're going to get very close to the end of the bond as our measure of the average time that we receive those payments. Now we'll discuss the modified duration, and here the modified duration is Macaulay duration divided by 1 plus y, or the yield to maturity. And this gives very close to the percent change in the bond price relative to the yield change. So if we want to calculate the modified duration, we take the Macaulay duration and divide it by 1 plus the yield to maturity, and we get 3.82. Here what this means is, or you can roughly interpret it as, if we have a 1% change in the yield, we will get a 3.83% change in the bond price. And it's an inverse of it, so it'd be negative of that. And if you look at that, you'll note that it is very close to the Macaulay duration. So the length of the bond has a very large impact on how the change in the bond price will react to the yield to maturity. That is particularly true at the low yield to maturity rates that we are currently at. For the calculation of Macaulay duration for a zero coupon bond, or our treasury bill example, it's very easy. The Macaulay duration equals the length of the bond. So for our 6-month T-bill, the Macaulay duration would be 1 in the semi-annual case, or 0.5 years in the annual case. It just simply equals the length of the bond because all of the payments are at the end of the length of the bond. Modified duration calculation would be exactly the same as illustrated above. Here are the factors that impact duration, and you can see those through the formulas actually. Coupon rate, term to maturity, and yield to maturity. Coupon rate, as we lower the coupon rate, we will increase duration and hence volatility. Terms to maturity, we will increase duration with longer maturity. As you would expect, you push that payments out further. And yield to maturity increases with lower rates.